Hey class, Mr. Pizar. This is the video B for lesson 1.3 for grade 8. I can multiply and divide numbers in scientific notation. We're going to multiply and divide today. And if you come up with a vocabulary word, write it down as we go, but I don't have any for you at the beginning here. Okay, get that copy down. I can multiply and divide numbers in scientific notation. Here we go. So first example problem for you is we're going to start with multiplication. The good news is I think multiplication and division of numbers in scientific notation is easier than adding and subtracting them. So if I had a number like 3.28 times 10 to the 5th, and I wanted to multiply that by a number like 5.2 times 10 to the 4th, the first step that I do in a problem like this is I multiply the multipliers. That sounds kind of funny. Remember that the multipliers are the numbers that are being multiplied by the power of 10. So there's two multipliers in this problem. I like to look at this part right here, this whole number right here, as one number. So that's one number. And I like to look at this whole thing over here as one number. So I'm multiplying a number times a number. Well, to do that, this number is in scientific notation, and so is this number over here. I have to start by multiplying the multipliers, or I have to go 5.2 times 3.28. And when I multiply numbers like this, I try to put the shortest number on the bottom when I start my multiplication. So that's 16, that's 5, that's 6. Let's see, that's 40. Put my placeholder in here. 10, 14, 15, 16. Okay. So I do my multiplication. I do my addition part of the algorithm. Now decimal. I know I have 3 places to the right of the decimal point in my factors up here. So total. So 1 here and 2 here. So I'm going to need 3 in my answer as well. Check real quick to make sure my answer makes sense. 3 times 5 is 15. A little more than 3 times a little more than 5, around 17. I'm happy with that. So we multiplied the multipliers, and we got 17 and 56 thousandths. Okay? But we're not done yet because we've only taken care of the multiplier portion of this problem. But the next part is awesome. It's so easy. If you remember this property that we studied, a to the r times a to the s equals a to the r plus s. In other words, if you have two powers that you're multiplying together and they have the same base, you can add the exponents. So we have two powers that have the same base that are being multiplied together, 10 to the 5th times 10 to the 4th. So if we add those exponents, we get 10 to the 9th. And it's that easy. We multiply the multipliers, and I'm going to erase my work for that so I can write down the next step. And then the second step, multiply the powers of 10. Notice I didn't say multiply the exponents of the powers of 10. I said multiply the powers of 10, which means you add the exponents. Remember that property up here. Might want to write that down. And then write your answer in scientific notation. It's that easy. You multiply the multipliers, boom, that's 3.28 times 5.2 is how I got this number here. Then you add the exponents of the powers of 10. One more example problem for you, and it's how to divide. So this is division. And it's really done the same way. If I had a number like 3.0 times 10 to the 7th power, and I wanted to divide that by a number like 1.5 times 10 to the 5th power. Notice, remember what division means. It means I want to know how many times the number in the denominator will fit into the number in the numerator. So the first step in division is to divide the multipliers. Just like we did before, we multiplied the multipliers because we're multiplying. But now since we're dividing, we're going to divide them. So 3.0 divided by 1.5, move the decimal point in both numbers. I end up getting 15 into 30, which is 2. So this is going to equal 2 times something. What's that something? Well, the second step is divide the powers of 10. Now remember this property, a to the r over a to the s equals a to the r minus s. In other words, let me erase some of this so I can get more room. If you have two powers that have the same base and you're dividing them, you can subtract the exponents. We studied that just fairly recently. And so this becomes 10 to the 7th. Okay, let me plug in some numbers here. 10 to the 7th over 10 to the 5th, which equals 10 to the 7 minus 5, or 10 to the 2nd power. And so that's as easy as it is. You divide the multipliers, divide the powers of 10, and then finally write the answer in scientific notation. Oop, this is getting kind of sloppy. Sorry. I got myself all sort of backed up into a corner here. One more thing. I should have written my answer differently a little bit. So I should have written this as 2.0 times 10 to the 2nd because I want to keep the same amount of place values in my answer that I have in the problem. And I don't know if you guys have learned about significant digits in science yet, but that's part of the reason why. Just want to kind of keep things uniform. And so, sorry about step 3 being all kind of written funny here, but you guys probably knew step 3 already anyways. So, quick summary. When you divide numbers in scientific notation, divide the multipliers, divide the powers of 10. You're done. Awesome. There's a worksheet for both types of problems. So there's one worksheet for multiplication and there's one worksheet for division. There's not a lot of problems on there. There's just kind of a reminder. There's some notes on the worksheets themselves. And lastly, remember too what multiplication means. You know, we're taking this many groups of this number. And remember what division means. We're trying to see how many times this number in the denominator will fit into the numerator. So nothing really changes just because we're in scientific notation. It doesn't change what the multiplication and division mean. Okay, guys, good luck. Thanks.